What we're going to look at now is how to solve quadratics that can't be factored. So a little recap on how to complete the square. I'm actually going to skip this because I do this last within the classroom. So this is actually a topic I haven't covered yet, completing the square. So I'm just going to get right into what happens when we can't factor it. So we're used to seeing problems like, so far we're looking at x squared minus 7x plus 12, and we equal 0. So what we do here is, in order to factor it, we know we create two sets of parentheses. And what ends up happening is my first numbers have to multiply to that first guy. So how do I get x squared? Well, the only way I can get x squared is x times x. The next thing up, we have to look at or find numbers that will multiply to a positive 12 and add to that negative 7. So we list off factors of 12. So we got 12 times 1, 6 times 2, and 3 times 4. So if I look at these three pairings, the only way I could possibly get 7 is if I use that last pair, 3 and 4. So we're going to be using 3 and 4. Now we also have to remember we are multiplying to a positive 12. So we are either going to have a positive times a positive or a negative times a negative. So we have to pick which sign we are going to put inside the parentheses. So we end up with a negative number in the middle. So because we end up with a negative number in the middle, both will end up with negative. Negative times negative makes positive 12, and then negative 3 minus 4 will give me negative 7. And this, of course, is still equal to 0. So what we do now is we split it up with a t-chart, and each parenthesis will be set equal to 0. So we have x minus 3 equals 0, and x minus 4 equals 0. Now we have to solve for x, so we're going to add 3 to both sides over here, and we end up with x equals 3. And we'll do the same thing over here. To solve for x, we have to add 4 to both sides. And we end up with x equals 4. So we end up with two values of x that result in making my equation equal to 0. So this means if I took 3 and plugged it into my equation up here, my answer would be 0. If I take 4 and plug it into my equation, I'm going to get 0 as well. So x equaling 3 and x equaling 4 are my two answers. Now, what happens if we cannot do this? Meaning what we have is not factorable. What we actually have to use is what's known as the quadratic formula. Now, this is a formula that you do not have to memorize, because when you get to the New York State Regents exam, we are given this reference sheet. So we have a nice little thing that says we have a reference sheet. It's for all 3 courses that you take a Regents exam for. It's going to have conversions up top, and it's going to have a whole bunch of different formulas. One of them happens to be the quadratic formula. So you do not have to memorize it. So if you don't memorize it, fine and dandy, because you get it on the reference sheet when you take the exam. However, if you do memorize it, again, no real biggie. Now, because of my position and everything, I do have it memorized. If you want to memorize it, Pop Goes the Weasel is a good one. I don't do that, but whatever value of x we have, it's equal to the negative value of b plus or minus square root of b squared minus 4 times a times c all over 2a. So there's the quadratic formula. Again, we can write it down here in our little box. Again, it's also here on the right hand side of our reference sheet. So you can use that to your advantage. So how do I use the quadratic formula? Obviously, I got all these wonderful letters within the quadratic formula. What do they all mean? Well, remember, a quadratic equation or quadratic expression, the standard form is ax squared plus bx plus c. And if we're doing an equation, it'd be equals 0. Where a, b, and c are the values of numbers that we are given in a problem. A is always with x squared, b is always on x, and c is always whatever the standalone number is. So the first thing we do is identify the values of a, b, and c. Once we know the values of a, b, and c, we just plug them into the formula in order to get our answer. So if I have this problem right here, 2x squared minus 12x plus 14, notice I'm not changing it like I did in the previous ones where we went to x squared. When we use the quadratic formula, I will use it whenever my first number is anything besides 1. So here we have it in standard form, 2x squared minus 12x plus 14 equals 0, so we're good with standard form. A is not 1, so I'm going to automatically go to the quadratic formula. So step 1, identify A, B, and C. So A is always on x squared, so it's going to be 2. B is always on x, so negative 12. And C is always by itself, so positive 14. Now, what we have to do now is we have to work with the quadratic formula. Again, it is the negative value of b plus or minus the square root of b squared minus 4ac all over 2a. So now what we're going to do is we're just going to plug in all the numbers where they belong. So negative b means we have x equals the negative value of negative 12 plus or minus the square root of b squared, so negative 12 squared, minus 4 times a, which is 2, times c, 14, and that is all over 2 times a, so 2 times 2. And what I'm going to do is I'm going to go through and simplify each piece individually. So the negative value of negative 12 is, so we have negative value of negative 12 gives me positive 12. So we have 12 plus or minus the square root. And instead of doing 12 squared minus 4 times 2 times 14, I'm just going to do it all at once. So, because that's the neat thing about this calculator, we can do it all at once. So we have in parentheses negative 12 squared minus 4 times 2 times 14 gives me 32. All over 2 times 2, which ends up being 4. What I'm going to do now is I am going to simplify. So what happens here is when I simplify, can I simplify 32 by anything? Can I get a perfect square out of factors of 32? And the answer is yes. So we end up with x equals 12 plus or minus, and then if I were to divide 32 by 2, since it's an even number, I get 16. And 16 happens to be a perfect square. So what we really have is the square root of 16 times 2. And that's still all over 4. Now the cool thing is once I split it up like this, I can take the square root of each number that's underneath the symbol. So square root of 16 times 2 means I can take the square root of 16 and the square root of 2 if I want to. However, I'm not going to do the square root of 2 because it's not a perfect square. So we have x equals 12 plus or minus. And then if I take the square root of 16, so square root of 16, I get 4. So a square root of 16 is a solid 4. And then square root of 2, I will leave. So square root of 32 is in reality equal to 4 root 2. And again, whenever I take the square root, I get a positive or a negative answer. So hence the plus or minus 4 root 2. And we're still dividing by 4. Now the next thing, anytime I'm adding or subtracting things, as long as both numbers up top are divisible by the number on the bottom, I'll divide both numbers by that number. So 12 I can divide by 4 and 4 I can divide by 4. So I will end up with x equals, and then when I divide 12 by 4, we get 3. And then 4 divided by 4 is just 1. So we end up with 3 plus or minus 1 root 2. So that is going to be my final answer using the quadratic equation. This is not a nice number. It is not a solid number, which is why we are going to use the quadratic formula. We use the quadratic formula anytime we are given an a value that is not 1. So in this case, we had an a value of 2. So we use the quadratic formula right off the bat. We didn't try to factor it or anything to that nature. The other reason we use the quadratic formula is because it's always going to work. It doesn't matter if the equation is factorable or not. We can go right to the quadratic formula because it's going to work every single time. We will get an answer. Sometimes it's a nice answer, 3, 7, 10. Sometimes it's not a nice answer, like here, 3 plus or minus the square root of 2. So it all depends on the numbers we're given and what the process ends up going through. So here we ended up with an irrational number, 3 plus or minus the square root of 2. And again, quadratic formula, we don't have to memorize it, but it's here for you to use. It's the negative value of b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c are the numbers within our problem. And again, in order to use the quadratic formula, our equation has to be in standard form, meaning it must be equal to 0. So once we get into these practice problems here, for instance, number 1, solve for x, notice my equation is not equal to 0. X squared minus 12x equals negative 20. First step I have to do is I have to make it equal to 0. So I'm going to move the 20 on over. So here it's a negative. To move it on over, I do the opposite. So I'll add 20 to both sides. Now I can't add 20 to x squared or 12x. So what we really end up having is x squared minus 12x plus 20 equals 0. So in order to use the quadratic equation, we have to identify values for a, b, and c. So a is always on x squared, b is always on x, c is always whatever number's by itself. So here we have x squared. There's no number out front, so automatically it's 1. B is in the middle, so negative 12, and c is 20. And again, we'll use the formula up top here, so we can say x equals the negative value of b, which in our case is negative 12, plus or minus the square root, and we just said b was negative 12, so negative 12 squared, minus 4 times 1 times c, 20, all over 2 times a, 2 times 1. So negative 12, it just changes the sign on negative 12. So we end up with x equals 12 plus or minus the square root. And we're going to use the calculator to do the computations in here. So we have negative 12 squared minus 4 times 1 times 20. So we have 64. All over 2 times 1, which is 2. So first thing we do is we look to see if we can take the square root of 64. If we can, which we can, so we actually will simplify it even further. So instead of 12 plus and minus the square root of 64, it's now going to be x equals 12 plus and minus 8 over 2. So now because I can divide both numbers by 2, I end up with x equals 6 plus and minus 4. So now because I can do both functions mathematically, I'm going to split this up into 2 equations. So one is going to be x equals 6 plus 4 and x equals 6 minus 4. 6 plus 4 gives me an x value of 10. And then 6 minus 4 gives me an x value of 2. So that is using the quadratic formula, and we get nice numbers at the end, 10 and 2. Let's say we look at number 2 though, solve for x, 2x squared plus 9x minus equals 18. Again, here we have to have it equal to 0. We're not equal to 0, so step 1 is to make it that way. So 18 over here, there's no sign, so it's a positive. To move a positive on over, we subtract it. So 18 minus 18 means we are equal to 0 now. And I can't take 18 away from 2x squared or 9x. So we end up with 2x squared plus 9x minus 18. So now we're in standard form for quadratic formula. Now we identify values of a, b, and c. So a, b, and c. So a on x squared, 2. B on x, 9. C, a lone number, is negative 18. Now we're going to use the formula in order to identify values of x. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So we have the negative value of b, so negative value of 9, plus or minus the square root of 9 squared minus 4 times 2 times negative 18. All over 2 times a, 2. Well, negative value of 9 is just negative 9. Plus or minus. And then, again, we'll use the calculator. We have 9 squared. Put that in parentheses. 9 squared minus 4 times 2 times negative 18. So we get 225. So plus or minus the square root of 225 all over 2 times 2, which is 4. So again, once we're to the point where we have a number on the square root, I'm going to take the square of the number to see if I get a nice solid number. So take the square root of 225, and I get 15. So we have negative 9 plus or minus the square root of 15 all over 4, not square root of 15, just 15. And here I can split it up. So we have negative 9 plus 15 over 2 and negative 9 minus 15 over 2. Negative 9 plus 15, we end up getting 6 over 2. Negative 9 minus 15, we get negative 24 over 2. Divide them, so 6 divided by 2 gives me 3. Negative 24 divided by 2 gives me negative 12. So again, nice, even, solid numbers for an answer using the quadratic formula.